So let's take a look at Unit 7, Statistical Inferences, Lesson 1, being skeptical. All right, and so the first thing we have is our notice and wonder, and it's called headlines. And so we're looking at some ways that people use statistics. So we have this graph, and we have two headlines that are from a website, and we can see those down here. They don't actually have anything to do with each other. It's just three things that are pulled from a website. So the first thing, we have this graph, and it has change in global air temperatures in Celsius along the dependent variable, the y-axis. And then along the x-axis, the independent variable, we have the year starting at 2000 and going up to, looks like 2012. All right, and so then we have this dashed line, and then we have a solid kind of jagged line. So what do we notice and what do we wonder here about this graph? Well, the y values here are pretty small, so the change in air temperature is only looking at like increments of 0.2 of a degree. So it's the change rather than actual temperatures. And so a positive value means that the temperature is increasing. A negative value, or if it's going down, that means it's decreasing. But it's the change, not the actual temperature. I also noticed that here 80% of dentists recommend Acme toothpaste. So it doesn't say, what they like about the toothpaste or the brand. Do they just recommend using toothpaste and Acme happened to be the brand? I don't know. And then if you look at Pythagoras brand rulers measure 20% better, compared to what? 20% better than what? So who knows what they're talking about? What does it mean to measure better? That's something that I wonder. Is it more accurate? I don't even know. And then for number 2, why do dentists like that toothpaste? Did they survey all dentists? How did they come up with that percentage? Is there a certain kind of Acme toothpaste or just the brand? Don't know. Some things I wonder about the graph. What would it look like if we went further back in time? Or what would it look like if we actually used temperatures instead of just change in temperature? So there are lots of things that we can look at with graphs and with different headlines and things. All right, so we are going to take a look at some questions and study designs, and we are going to sort them into this type of study described. So we have surveys, which might be helpful for us to define. So surveys, and you can look in our agenda to see what those definitions are, but a survey is a set of questions. It's a set of questions given to people to seek their responses. All right, and then an observational study, you collect data. It's a study where you collect data without influencing the subjects directly. You're just observing. You're not doing anything to influence the subjects. So if I were to collect, if I were to collect test scores, that is observational because I am just collecting those scores and observing that data. I didn't affect how you did on the test. And then an experimental study, you collect data by influencing something to determine how another thing has changed. So you collect data by directly influencing So you've changed something. To determine how another thing has changed. All right, so we're going to take a look at these designs and see if we can't put these into categories. All right, so let's take a look at the first one. Why are students missing so much school in the district? A district administrator selects 300 names at random from the enrollment list and sends a letter to each student's home. The letter includes a page to be returned to their school signed by a parent or guardian. The page asks, how many days has your student missed school this year? And what are the reasons for missing school on those days? And so we're trying to decide, first of all, whether the study is good or bad, and determining what type of study it is, okay? And so in this case, they're asking questions to collect data. So that is going to be a survey. And I believe, I'll try to color code this. So it's a survey. And then the design is all right, but parents might not remember how many days their kid missed or why they missed school, or they might not want to tell why their child missed school. So it's okay, but it's not great. It might not actually collect the data that we want. All right, number 2, why are students missing so much school in the district? Same question. A district administrator chooses one of the elementary schools in the district and asks the principal to provide information about the number of absences and the excuse notes provided to the school. So this is going to be an observational study because they're just collecting data. They're not asking people for opinions or information. They're just collecting data or information that has already been provided, and they're not influencing anything. And this design is really not great because they're looking at, the question asks in the district, and they're only looking at elementary schools. So the number of days and the excuse notes could be very different at the high school level or at the middle school level. And then also, like at the lower grade levels, you tend to have more outbreaks of contagious diseases like the flu because those kids don't have as good of hygiene. And so it's possible that it could be skewed data. All right, number 3, what type of sweetener do flies prefer? A scientist puts the same amount of each sweetener into different bowls of water and counts the number of flies that drink from each bowl in 4 hours. Again, this is observational because the scientist is just putting out the bowl. He's not, or she is not doing anything to influence the subjects. They're just putting it out and looking at, the different bowls and how many flies drink from that bowl. It's a pretty good design because you're looking at, which type of sweetener do they prefer? And then you're just letting them drink from the bowls. So flies, you would think, would be attracted to the sweetener they like and drink more often from it. Again, same question. What type of sweetener do flies prefer? A scientist divides the flies into different groups and gives each group only water with a certain type of sweetener in it for 3 days. The scientist then does a test on each group to see how well the flies can fly through a maze. So this one is an experiment. It's an experimental study because they're actually doing something to influence the flies, right? And then this one is not a good design. It doesn't even address the original question, what type of sweetener do flies prefer? It's actually looking at how well they fly, which has nothing to do with what they prefer. So that is not a good design. Number 5, is there a link between dark chocolate and weight loss when compared to milk chocolate? Ooh, that's an interesting question. A nutritionist asked 5 friends to eat dark chocolate along with their usual food for 6 months, and 5 other friends to eat milk chocolate along with their usual food for 6 months. The nutritionist then compares their weight after the 6 months to their weight before eating the different chocolates. So this one, again, is an experimental because they are doing something to influence the subjects, right? They're making them eat chocolate. Oh, darn. It's not a great design, though, because it doesn't really address the actual, it addresses the question, but it doesn't, really determine whether or not dark chocolate is better or worse than milk chocolate. There aren't that many people in the study. It's really small. There's only 5 friends for each. That's a very small study. We also don't know anything about what their typical diet is, what their typical exercise regimen is. And so there are so many other factors that could be involved here that might affect whether or not they lose weight. So really just looking at the kind of chocolate isn't going to help answer the question. All right, number 6, again, the same question. This time a nutritionist gathers 60 people selected at random, then randomly assigns half of the group to eat a single dark chocolate bar after dinner each night, and the other half to eat a single milk chocolate bar after dinner each night for 6 months. Everyone is to keep track of the other food they eat in an app provided. The nutritionist then compares each person's weight after the 6 months to their weight before eating the different chocolates, accounting for the other calories consumed. So again, this is an experimental. And this one is definitely better than the first one. They're chosen at random. The people are chosen at random. So there's a good chance of getting different kinds of people in each group. So it might not, body type might not matter as much, might not affect the data as much. Same thing with activity level. It's more random, so it'll be more balanced probably. So this one is definitely a better study, although it's not the best, but it is a pretty decent design. All right. Do voters in the district favor a sales tax increase of 1% to fund the Parks and Recreation Department? A politician sends a letter to 300 voters in the district asking, would you pay extra money on your essential groceries to hire more government workers to plant flowers around town? Well, this is a survey, and this is a pretty pitiful survey if you ask me. So first of all, they are kind of placing bias by the way that the question is even asked. They're saying, would you pay extra money? And so when people hear extra money, they automatically think, oh no, this is something bad. So on your essential groceries to hire more workers to plant flowers. So it seems like something small, planting flowers. It doesn't actually answer the question about sales tax increase funding parks and recreation, because they're making it sound like you're going to lose money for flowers, and that seems very insignificant when maybe that's not really what the money's going towards, and it's going to lead people to really say no, even though they might not fully understand the original question. So this is not a good survey. It's a very biased question. All right, so now we have the same question again, or initial question. and the politician sends a letter to 300 voters, again, selected at random in the district, would you be in favor of a 1% increase in sales tax to fund the Parks and Recreation Department in town? Now, this is a survey, again, and it's a decent survey. It's okay. It's actually asking the question that they want the answer to, and it's not leading to a specific answer. It's not encouraging them to say yes or no. It's just flat out asking the question, and so it's a decent survey. So are you ready for more? A college student wants to study how sleep impacts college students. Ask a statistical question about this topic that can be answered with a survey. So you could say, how much sleep do college students get on average? All right, so how much sleep do college students get on average? All right, ask a statistical question about this topic that can be answered in an observational study. Do college students who get less sleep tend to have lower grades? And then finally, we're going to ask a question that can be answered with an experiment, right? So does an app which reminds college students to go to sleep have an effect on how much sleep they get? And there are lots of different questions that we could come up with. These are just some examples. You could come up with some other questions on your own that would address these same issues. All right, so let's take a look at the next part. And here is your summary. So you can take a look at what the different kinds of studies are again, surveys, observational studies, experimental studies, and think about some different things that a researcher might need to consider right here when they're coming up with a study, right? They want to select subjects that are representative of a larger population. Randomizing is a great idea. How subjects are selected for the study or assigned to groups, again, randomizing is helpful. Making sure that the question doesn't lead subjects to a certain answer. Making sure the data is collected and analyzed fairly. Using a sample that is large enough to detect differences in the presence of variability. And collecting data directly related to the question being asked. So those are some considerations that a researcher might need to use when they want to collect data to answer a certain question.